Hello, Year 6. Hope you are well and you are having a good week. Today we're going to look at distillation. And distillation is a method to which if we've got a solution and we want to remove the solvent from that solution, distillation is the best way to do so. So I'm just going to go through the equipment that we need to carry out distillation first, and we'll go through exactly how to carry out this practical. So the equipment that we need to start with is a Bunsen burner, we need a tripod and a gauze. We've got a flask here, and the flask is responsible for holding our solution. Above the flask we've got a thermometer so we can keep a track on the temperature inside of the flask. Very special piece of equipment here, and this piece of equipment is called a Liebig condenser. Okay, Liebig condenser is fed down into a beaker, and we've got two tubes attached to the Liebig condenser. Water in is coming from the tap around the Liebig condenser and out the other side. So that's the equipment that we need. Let's go through exactly how the distillation works. So in here we've got our solution. Our solution today is a red dye and water. Now distillation is a good method to remove the water, leaving behind the red dye. So to start with, we're going to light our Bunsen burner. The gas is not on at the moment, so I can't light it. So light the Bunsen burner and start to heat the solution. Now we know the boiling point of water is 100 degrees. So once this reaches 100 degrees, what should be happening is the solvent, the water, should be evaporating, turning into a gas and making its way into the Liebig condenser. Now, why is the Liebig condenser a special piece of equipment? Now, the Liebig condenser is really special because of the way it's built. The hot gases go down through the middle, and around that tube with the hot gases is lots of cold water flowing around it. Now, what does the cold water do? It will remove the thermal energy from the very hot gas that's passing down the Liebig condenser, and because thermal energy is being removed, the water vapor will condense. Because the water vapor is condensed, the water will trickle out the Liebig condenser and will be collected in our beaker. Okay? What do we call the water that is being collected in the beaker? We call it distillate. Another question that always comes up as well is, why do we have the water in down here and the water out from the top? So having a look, if it was the other way around and the water came in at the top, the water would merely flow down the Liebig condenser and out the other side. That probably wouldn't be able to cool down all that hot gas in there. So what we would end up with is hot gas coming out of the other side. That's why we've got water coming in from the bottom. The water coming in from the bottom floods the entire Liebig condenser on the outside and comes out the other side. So that entire length, all the way around the Liebig condenser, is nice and cool. Okay? Another thing that we can use distillation for is separating two solvents that have been mixed up together. So, for example, water and ethanol. Boiling point of water is 100 degrees. Boiling point of ethanol is about 78, 79. Now, how would we separate two liquids when they look pretty much identical? Somebody just coming in the door how would we separate two liquids that were pretty much identical? So the boiling point 107 and 78. So we would heat the mixture of those two liquids up to 78 degrees. Now, if the boiling point of ethanol is 78 and the boiling point of water is 100, if we heat the mixture to 78 degrees, that means the ethanol will evaporate and come down the line in condenser, condense, and the ethanol will form our distillate. What will remain behind in the flask or water will, because the boiling point of water is 100 degrees. Okay, so that is distillation. I feel incredibly bad that you're not here to do it for yourselves. But if you've got any questions regarding distillation, drop me a message or refer to the Bite Size website. Okay, thank you.